Hey, we're going to talk about maximizing profit now. Same concepts apply as we used for maximizing revenue. We're just looking at a different characteristic here. So the first thing I just want to remind you is that profit in general equals revenue minus cost. Okay, so just kind of keep that in mind and look for these characteristics if they're not quite obvious. All right, example. A company estimates that its daily total cost function is C of x equals x cubed minus 6x squared plus 13x plus 15. And its total revenue function is R of x equals 28x, where x is a number of units. Find the value of x that maximizes the daily profit. Okay, so we're going to set this up. We're going to have profit equals revenue, which is 28x, minus the cost function. So minus the quantity of x cubed minus 6x squared plus 13x plus 15. Let me clean up my little 13 there. It looks a little scary. Okay, so let's collect some terms before we actually take a derivative. So we'll have negative x cubed plus 6x squared. We'll have 28x minus 13x. So that looks like plus 15x, and then minus 15. One thing to note here, there's many ways we can do this, and I mean you can graph yourself to check and answer some questions, but this is a cube function and it's a negative cube function, so you should be able to pick up from days gone by that it looks like an upside down cube, which the cube when placed upside down looks something like this. So it could have like a minimum and a maximum, and if it's an upside down cube, that's the order they have to come in. Okay, so let's just kind of continue this on and see what happens. So the derivative would be p prime of x equals negative 3x squared plus 12x plus 15. So I'm going to set that equal to 0, and so that I can figure out where these turning points are. And because it's a quadratic, it's most likely going to give me both of these turning points that I'm talking about for an upside down cube. If you don't know it's an upside down cube, there's other ways to figure out what we're doing, but this will be the quickest if you have that knowledge. So set it equal to 0 to figure out where it goes flat. I'm going to pull this negative 3 out, and that'll leave me with x squared minus 4x minus 5. So as I continue my journey, I can factor that quadratic. It'll be x minus 5x plus 1. So what do we got here? We get x minus 5 equals 0, x plus 1 equals 0. So I get two values, x equals 5 and x equals negative 1. So as I said, there's two things really that kind of help you out here. One, it says find the value of x that maximizes the daily profit. So the company is not going to make negative 1 items. That doesn't even make sense. So first of all, the negative 1 is gone. So while the function graphically may look like an upside down x cubed, the application doesn't really start it over here where we would consider x as a possibility of being negative 1. So x equals 5 is the only good answer, and if you think about the upside down cube function, as I said, they would come in that order, minimum then maximum. Okay, so that's the number of units to maximize the profit. All right, let's look at this next one. A small tie shop sells ties for $3.50 each. The daily cost function in dollars for X number of ties sold is estimated to be C of X equals 0.0006 X cubed minus 0.03x squared plus 2x plus 20. Find the number of ties that will maximize the store's daily profit. So again, they're not actually asking us for the profit. They're just asking us to figure out the number of ties. So let's go back to our profit function. P of x will equal the revenue, which will be $3.50 per tie times x. So that's a price times a quantity. So they sell for $3.50 each. So $3.50 would just be selling one tie. So we want to make sure we have a actual revenue function. So that's our revenue. And then minus our cost function, which likes to use some zeros here. So let's collect some like terms here. P of x equals negative 0.0006x cubed plus, because I got to distribute a negative here, 0.03x squared. Then I'll have 3.5x minus 2x, so that'll be plus 1.5x, and then minus 20. So that's the function that would calculate the profit for selling x number of ties. So the derivative, p prime, will be negative 0.0018 x squared plus 0.06x plus 1.5, and we're going to set that equal to 0. Oop, too many zeros. But we're setting our derivative equal to 0. I think the best thing for me to do here is to use the quadratic formula. Okay, so my quadratic formula here, the a would be negative 0.0018, the b would be 0.06, and the c would be 1.5. So let's see here. This x will be negative b, so negative 0.06, plus or minus the square root of b squared, so 0.06 squared, minus 4 times a, negative 0.0018, times c, which is 0.15. All that's under the root. And then at the bottom we'll have 2a, so 2 times negative 0.0018. So let's give me a minute with the calculator and see what type of answers I get. Okay, I'm going to pause it while I play with the calculator. Okay, I'm back. So I ran through the quadratic formula and I got two answers here. The first one, I'm just going to round off. It's tedious plugging this into the calculator, so be careful. It's negative. One of the answers I got was negative 16.6-ish, and the other one was exactly 50. So let's talk about these. Well, first of all, we're selling things. We're selling ties. Tie shop cannot do very good if it sells negative number of ties. So it's implied that our domain from the application would be x has to be 0 or greater, not a negative. So we're just going to throw out the negative, and that leaves us with the 50. Now, a lot of things could happen, but again, over here we've got that negative x cubed. So that's the upside down cube function that has two turning points. One of them happened to be when x was negative 16.6. That would be the first one, so that would be a minimum. And the other one would be a maximum when x is 50. So they need to sell that many ties to maximize profit. Okay, next example. In the planning for a sidewalk cafe, it is estimated that for 12 tables, the daily profit will be $10 per table. Because of overcrowding, for each additional table, the profit per table, and that means every table, will be reduced by 50 cents. How many tables should be provided to maximize the profit for the cafe? Okay, so this is a little bit different than the other ones because in the other ones we had revenue and cost and we calculated the profit function. But in this case, we're already told what the base profit is and we're adjusting it. So let's kind of think about this. Okay, it is estimated that 12 tables will have a profit of $10 per table. So if we do like a price and a quantity, we could do 12 tables. And what are we going to do? We're going to add tables to that. Okay, so this over here is our tables. And we're going to have $10, but as we add tables, the profit goes down. So that's profit per table. So let's see what happens here. How's the adjustment go? It says for each additional table, okay, so we're going to add X, the profit would decrease by 50 cents per table. So that's 50 cents X. Okay, so the thing to keep in mind here is X is the number of tables over 12 because we're starting with 12. So let's kind of clean this up. We're going to fold this out. So we'll have 120 minus 6x plus 10x minus 0.5x squared. I'll collect like terms and rearrange. So profit will be negative 0.5x squared plus 4x plus 120. So derivative now to figure out where this thing is turning, and it's a quadratic. It's an upside down quadratic. So an upside down quadratic is an upside down U that should have one turning point, which is a maximum. So right now the derivative will be negative x plus 4. So we're going to take that and we're going to say set that derivative equal to 0 to figure out where that turning point is. 0 equals negative x plus 4, x equals 4. That's 4 additional tables. So that means 12 plus the 4 would give us 16 total tables to maximize the profit. Now, you could go back and answer a couple other questions. If you plug that 4 into the profit per table, I believe that means you would make $8 per table. $8 profit per table is not asking you that question, but it's good to interpret. And if you plug the 4 in, you would get basically 16 times 8. What is that? $128 is the max total profit. Okay, it only asks you for how many tables, which is 16. So just be careful of that. All right. Thank you.